Hello and welcome to another Data Analyst tutorial on Python. Today we are going to dive into 7 functional programming techniques to enhance your Python code. So today we are going to emphasize more on Python coding, okay? So what are those 7 functional programming techniques that can enhance your Python code? So first, let's talk about first-class functions, okay? Now, first-class function in Python, functions are first-class citizens. This means they can be passed as arguments to other functions, returned as value from other functions, and assigned to variable. Okay, now let's work on an example. I have my function here, great, then name, then return, hello, name. Okay, then function executes value return value. So right now we are passing the greet function as an argument to execute. Okay, so now we are going to have results is equals to execute greet Abdul Now let's print it out. Print results. So now we are passing the greet function as an argument to be executed. So now we are going to execute this, and what I'm expecting should be hello Abdul. Okay, so let's do that. Fine. So here, the greet function is passed as an argument to the execute function, demonstrating the functions can be treated like any other objects. Okay, so now let's talk about higher order function. Higher order functions are functions that can take other functions as arguments or return them as results. Okay, let's take a look at this example. Now we have our function, then add, okay, then we have our x. Okay, now return x plus 1. Okay, so now def apply underscore function. Okay, and then we have our fun, then value, return. Okay, so right now I'm passing the add function to apply function. Okay, so now result is equals to apply function. Okay, that is it. Then we have hard. So now let's print results. Okay, so let's execute it. So now we have 6, okay, as the output. Now, in this example, apply function is a higher order function because it takes another function add as an argument. Note that, okay? It takes another function add as an argument. So that is how it works. Okay, let's talk about pure function. A pure function is a function where the output is determined only by its input value without observable side effects. Okay, so let's take a look at this. We have our def pure underscore sum with the bracket A, then B. Okay, now return A plus B. So right now we are going to call the pure function, so which is result is equals to pure sum, which is 3, 4. So now let's print results. Okay, so now let's execute it. Okay, so now we have 7. So pure sum is a function because it consistently produces the same output, giving the same input and does not modify any external states. Okay, so this is how it works. Let's talk about immutable data structure. Okay, immutable data structure don't change their state or data after they are created. Okay, now these help avoid side effects. Now let's take a look at this. Now I have my def append underscore to underscore tumble. Okay. Okay, then I have my TPL, then value. Okay. Now return plus value. So now the original tumble, that is what we want to create now. Okay, now let's create the original tumble. So we are going to have my underscore tuple, which is equals to 1, 2, 3. Okay. So right now, creating a new tuple by appending a value, that is the next step. So we have new tuple is equals to append. Okay. So we already have it here. That's it. Then right here we put my underscore tuple. Okay, we give it a comma, then 4. Okay, Now, what is next? Now, let's print our new table. Okay, so let's go now. Print. Okay, so print what? Print new underscore table. Okay, so now let's execute it and see. Okay, so this is it. So we have 1, 2, 3, and 4. Now, one thing you need to take note here. Instead of modifying the original table, a new table is created with the hard value. So this is how it works. Let's talk about the lambda function. Okay, lambda function are small anonymous functions defined with the lambda keyword. Okay, so now let's take a look at this example. So now we are defining a lambda function to add two numbers. So we have add is equals to lambda. Okay, we have our x, comma, y in column, then we have x plus y. Okay, so now let's move down. Now let's use the lambda function now. Okay, so we are going to say result is equals to add 3, 4. Okay, so now let's print it out. So print results. So let's execute it. Let's execute it. So, okay, so now we have 7. We have 7. Now, note, the lambda function is a concise way to define a function that had two numbers. Again, the lambda function is a concise way to define a function that had two numbers. Let's talk about map, filter, and reduce. Okay, now these functions are used to apply a function to a collection of items. That is map. Okay, now for filter, filter item out of a collection. That's what filter does. It filters item out of a collection. Now we have what we call reduce. It reduces collection to a single value. Now let's take a look at this example. So right now I'm just going to copy the code and explain better so we can have a clear picture about it, okay? And I'm going to include some comments so we can all understand it. So right now, let me just paste it, okay? Now, so first, from font tools, we have to import our reduce. So right now, we have our number here as a variable. So we have our 1, 2, 3, 4. So these are the number we are going to use, okay? Now, the next stage now is that we have to map our numbers, okay? Now, using map to square each numbers. So we have to map each number, square them out. So we have to create a variable with the list, and then we have to use our lambda function, okay? And our x raised to power 2. So we have to print that out. And the next stage, let's talk about filter. For filter, we have to filter each even number. So we have a variable here called even, then we create a list, okay? Now our list is there with filter, then we have to use our lambda too. Then we have to print it out here. Now let's talk about reduce. Now we have to reduce to sum of all number, okay? We have our total as variable and then reduce lambda xy in column and number. In summary, what we have here is just function that we can use to apply, okay, collection of items, right? So now let's execute this and see what the output will be. So now this is it. So for our map, we have 1, 4, 9, 16, 25, and then for the filter, we have 2, 4, and then for the reduce, we have 15. This is how it works. Okay, let's talk about recursion. Okay, now recursion is a technique where a function calls itself in order to solve a problem. Now let's take a look at this. So I have my def factorial n and close the brackets, give it a column, and then if n is equals to 0, okay, return 1, else return n factorial. So we have our n minus 1. Okay, so right now let's calculate the factorial of 5. Okay, now so it's going to be result is equals to factorial. Okay, so 5, they'll close the brackets. So let's print. Now print results. Okay, let's execute it and see. Okay, so we have 120, okay? We have 120. So in this example, the factorial function calls itself to compute the factorial of a number, demonstrating the use of recursion. So this is how it works. Thank you. In summary, by incorporating these functional programming techniques, you can write more modular, reusable, and maintainable code. Each technique offers a different way to approach problems and can be particularly powerful when combined. Okay, so let's do some recap. First-class functions treat functions as first-class citizens. Okay, higher order functions use functions that take or return other functions. Pure functions write functions with no side effects. Then immutable data structures use data structures that don't change. Then lambda functions create small anomalous functions. Okay, then map, filter, and reduce process collection in a functional style. Then lastly, we have recursion. It solves problems by having functions call themselves. Please kindly subscribe, like, and share for more videos. Thank you.